All right, so this is where we left off for 6.4, and as I mentioned, I'm going to show you synthetic examples 8 through 10, and maybe I could even show you with, well, not exercise 7. The issue with exercise 7 is that we have this leading coefficient that's not 1. So, but as a reminder, for those that are familiar with difference of cubes, we have 4x is being cubed to get this thing, and then 5 cubed gives us this thing. So if you remember from that difference of cubes, we would write it as 4x minus 5, and then it would be 16x squared, because you have to square both the 4 and the x, and then you have to multiply, and you change the sign, so it becomes plus. 4 times 5 is 20 x, and then always positive because you have to square that 5, so it's 25 there. So without even doing anything, I already know the answer is this 16x squared plus 20x plus 25, because the problem is factorable. Well, we can do long division to actually show the work. So 4x minus 5 is being divided by, what you would want to do is put in some x squareds in there. 0x squared plus 0x minus 125. If you're struggling with that fact, just think about for a second, what could you put as a leading coefficient so you could include the x squared? Well, 0 times anything is 0. So this is equivalent to what we started with. So what times 4 would give me 64? That answer is 16. And what times x gives me x cubed? That is x squared. So as you multiply, get that 64x cubed, and 16 times 5 is 80 x squared. And as I subtract off each piece, that turns into a plus. So these cancel and go back to blue. I have 80x squared. So what times 4 gives me 80? That answer is 20. And what times x gives me x squared? X. So 20x times 40x, sorry, 20x times 4x is, scroll down a little bit, 80x squared, and 20 times 5 is 100x. And as I subtract, these cancel, and then add, you get 100, and bring down that minus 125. And I think the last piece would be, well, 4 times 25, 4 quarters make $1. You get 100x. 25 times 5 is 125, and as you subtract off each piece, you get a remainder of 0. I think it's important to also mention that if you get a remainder of 0, so 0 is your remainder, you could write out plus 0 divided by 4x minus 5, what you divided by, except 0 divided by anything is still 0, and adding it is not going to change the value. So I think it's important to realize some of those things. So again, before we do synthetic, I just want you to recognize long division always works. But synthetic, there's a T right there, except it doesn't show up for some reason. But anyway, I like to think about only using synthetic when it's a binomial, a linear binomial at that. So that means the exponent needs to be 1, and the leading coefficient must also equal 1. So you can do synthetic if you have other types of linears, that are not a leading coefficient of 1. It's just complicated, and I don't want to overcomplicate things. And I recognize that the way I do synthetic is different than your Algebra 2 teacher, because I like to put the opposite. So because it's x minus 3, you put positive 3 in the box. So let me write that down, the opposite. And then I typically write a little bit differently, where I put a line down here, and then you want your coefficients up here. So to do synthetic, you just add straight down. Well, there's nothing to add to 2, so you just bring this down, and you multiply by what's in the box. That's why I put it in a box, because we go back to it over and over again. 2 times 3 is 6. Adding straight down, -1 plus 6 is 5. Maybe I should write that down. You add as you go down, and you multiply by what's in the box. 5 times 3 is 15. Add straight down is 2. Multiply by what's in the box. Adding straight down. This last number is your remainder. So there's a couple ways you can think of this. Is you can start with the remainder and then go backwards, like this is the constant, this is the linear term, this is the quadratic term. Or if we start with a cubic and we divide by a linear, we remove 1 from the exponent. So your answer is 2x squared plus 5x plus 2 plus your remainder over what we divided by. And when you get a lot of practice, this happens really quickly. So put the opposite in the box. 4, -3, 6, 5. And just like what I did in the previous problem, if you ever skip a term, you need to write a 0 down, to hold the place. So bring the 4 straight down, multiply by what's in the box. So 4 times 1 is still 4. Adding straight down, -3 plus 4 is 1. Multiply by what's in the box. Adding, multiply, and adding, and that's your remainder. So we have 4x squared plus 1x plus 7 plus your remainder over what we divided by, x minus 1. Notice that I'm going back to this piece for the what I divided by, not what was in the box. So that is very important. One more thing to mention is the remainder theorem. And the whole premise is that you can use synthetic to actually evaluate functions. So p of 2, if I asked you to plug that into this problem, it would be 2 cubed minus 5 times 2 minus 2. Only 2 cubed, 2 times 2 times 2 is 8. So you're looking at 8 minus 10 minus 2, which would give us -4. Well, if I asked you to use synthetic division to find the remainder, you put the opposite in the box. So notice the relationship between, let me use a highlighter, p of 2, and that I'm examining x minus 2. And synthetic, you do the leading coefficients, but notice I'm missing the x squared term, so I need to put a 0. So let me write that down. You need a 0x squared term in order to do this. And then -5, and then -2. So bring the 1 straight down, multiply by what's in the box, adding and multiply, adding and multiply, and adding. The remainder, -4, is equal to the value of p of 2. That's called the remainder theorem, that they are equal. It's called the remainder theorem because we're looking at the remainder. Which will make doing problems very, very easy. Like, I don't know how many of you would really want to go to a calculator and figure out what 4 to the 6th power is times 4 times 4 to the 5th minus 20. There's a lot going on here. So if you use the remainder theorem and synthetic division, now notice that it is the same, when you're doing p of 4, you do not change the sign. So it is the same sign. So we have 4, -25, 35 to the 4th power. We need a 0 for the cubed. See how 6, 5th, 4th, 3rd. 17 for the squared power. We need a 0 for the 0x, and then we need one more 0 for the constant term. And the answer that we get will be whatever's in the remainder here. So bring the 4 down, multiply. Well, that's -9, right? That'd be -36, right? Multiply. Anyway, you get -1, -4, -4. Multiply, you get -16. We get 1 times 4 is 4. Adding to 0 is still 4. 16. There you go. Therefore, p of 4 must equal 16. And we didn't have to waste any time going to a calculator. Some of you may have needed a calculator to do this arithmetic, but I don't know how good you guys are. But certainly a useful theorem if you are good with this method. Anyway, you should be ready for the homework now. I didn't try to overburden you with too many problems, but enough to be helpful for you to learn something. And maybe you learned this in algebra too, but we were just kind of coming full circle, and now it actually makes sense.